Hi, everyone. So my name is Dr. Harjinder Sembi, and I'd like to welcome you to the School of Physics and Astronomy. So I'm just going to give you a quick overview of our physics programme, our school and our university, and also why I think it's a very rewarding degree for you to come and do with us and how it can give you lifelong benefits. And I should say at this stage, actually, I studied physics and space science at this university and in this department, and now I'm a professional scientist and a lecturer in the school. And in my own particular research area, I use space measurements to study the Earth's climate and environment. So I'm just going to give you a short overview of some of the interesting facts about our university and what we offer, and then lead you into why physics and why this school. So first of all, if you had just three things to take away with you from this talk as to why you should join our school, and I think here we have three very good reasons. First of all, we really care about teaching excellence, and this really is embedded throughout our entire programme and school. We conduct world-class research, and this is evident through lots of our research programmes and research groups we have within the school. And the last thing is that we really do have a strong focus on student support, really actively supporting how they learn, supporting their well-being, and how they can manage their life throughout their degree so that they can go on to get the sort of jobs and continue in the sort of research areas or further education that they want. So just to give you some information about our university first, if you don't know it, we do have, we're quite proud to say that we have a continuous history of getting lots of different types of awards, and two that we're particularly proud about at the moment is that there are a couple of newspapers and things that have given us University of the Year awards. So one's Daily Mail, the other one is that we've been twice shortlisted as the University of the Year by the Times Higher Education, and also the Sunday Times University of the Year for 2025 awards. So we're really pleased about that. So, and again, when it comes to awards, we've been rated gold overall for our teaching excellence framework, and I'll mention this a little bit later, but this is really the highest ranking possible, and this really comes from our outstanding student experience and the outcomes that we get from our teaching. And finally, in terms of the National Student Survey, we're in the top 30 for the overall positivity in the 2024 National Student Survey, so we're really pleased about that as well. Just to understand what our students say, this is again just a little slide showing what some of our students say about the university. They like being on the campus, they like the student support that they get from the peers and the colleagues, and also really how much the staff care about, the staff and the teachers care about how to help the students push towards excelling as much as they can and do well in their studies. A couple of facts about the university and what you can get. So firstly, one thing that we're quite happy about and we're very pleased about is that all first years are guaranteed accommodation. So this is, you can get more information on this on the digital open day survey student pack that you would have, or email that you would have received. So you get some of this information, but basically, you know, it's very affordable. There's free shuttle buses from some of the locations. And what we're really happy about is that all students, first year students, are guaranteed accommodation. This is really important, especially when you're starting at a new place away from home. If you would like more information on this, you can attend accommodation talk at 6 o'clock. And I think this should be in the information email that you got about this event. Something else I'd like to just mention is the fact that you can get lots of scholarships. So there is a nice website here, le.ac.uk/scholarships, where there's some information about the types of scholarships available to students. And there's two at the bottom that I've added here. There's one called the Margaret Rankin Pitt Scholarship. So this is specifically for female undergraduates in physics. So this one is specific to the School of Physics and Astronomy. And there's also another one, John Day Scholarship, which is just being confirmed, but this will be available to any mature students who are interested in coming to the school. And we'll give more information about this once you start in September, should you wish to come here. So I'm just going to move on to what our school is actually about. So just in case we have some students, prospective students who are still undecided why physics, you know, what is physics? And I think this is really nicely epitomised by this Institute of Physics quote. It's a study of how the universe behaves, and it's the application of that knowledge to help improve lives. So it's really the study of everything from the smallest particles to the whole universe. And what really is important is to understand that by understanding how the universe works, it really gives us power to change the world. basically, and we can do this through a number of jobs, and I'll talk about this a bit later. So just going to tell you about our school. We're a medium-sized department, but we have very strong heritage in physics and astronomy. Our teaching is all done according to the Institute of Physics best practices, and we're really proud that we win lots of accolades for our teaching quality at least every year, and from our students particularly. They really value the supportive and inclusive environment that we try to produce in our department. We attract approximately £14 million per year research income, and this comes into our research, our sort of world leading research groups. And this is actually really important because lots of the lecturers who teach you are world leading scientists. They are working in world leading research groups, and what this means is that this allows our students to get access to lots of cutting edge research activities, and this is particularly important when our our undergraduates might want to do third and fourth year projects with us. So it's really important that this kind of research, active research, can be embedded into lots of the parts of the physics program that we offer. And again, coming back to the research focus, a lot of elements, especially the third and fourth year research projects, are very much focused on this research-led training and teaching. And I should mention that we're one of the only departments, one of only 11 universities specifically in the UK to have received the TEF, Teaching Excellence Framework Gold Award, and we've also ranked in the top 30 for the Research Excellence Framework. So these are both really important in terms of deciding how well we do on the terms of our research excellence and our teaching excellence. And in terms of the last national student survey, we were ranked overall 7th for all physics departments in the UK in terms of overall positivity within the NSS. So I'm just going to talk to you briefly about our courses. So there's 5 or 6 or so courses that we offer. So we have straight physics, which can be done as a BSc 3-year course or an MPhys 4-year course. But you can also do the physics with particular flavours, so with astrophysics and space science. And I'm really pleased to announce that we've got 2 new flavours of 2 new degree programs that we're just going to be starting in 2025. So if you apply here, you'd be some of the first students to have access to these new degree flavours. So we have one with climate science, and then we have one which is physics with data science. So we're really excited to bring these into the fold. And finally, we also have physics with a foundation year. So this would be a BSc 4-year course, and this just basically means you get to do a foundation year before you start onto the first year physics degree. First year physics, basically. And lots of the new modules are very central to the streams that will be available as electives for all students starting in 2025. So I'll just tell you what the electives are in a minute as well. So one of the things that we're really happy about is, and what we really try to do, is make sure there's an element of flexible learning. So you get to personalise your degree as you go. And what this means is that alongside the core modules that you do, you get to do these other additional modules which are called electives, and this is what allows you to start to choose what way you want your degree course to go. So basically you could change your flavour, so perhaps you start on straight physics but you do some electives in astrophysics and you decide actually I want to graduate with a degree in physics and astrophysics. So this means that there's some time over the course of the first and second year where you can switch between these, and you can also during the course of the degree as well, you can also switch between doing a 3-year BSc or doing a 4-year MPhys. You can, if you wish to, add a year abroad or a year in industry, and you can also choose very specific modules that are such as industrial projects, hands-on education modules, outreach activities, and many, many more things. And I'm just going to describe those to you briefly. So if you are interested in study abroad, we have 4 options that are available to our students, and they do this in their 3rd year. So there's South Africa, Netherlands, Canada and Australia. And basically what happens here is that the students return to complete their final year of the studies at Leicester. So they either would still get, they would have a 4-year BSc or a 5-year MPhys if they decide to choose a study abroad option. It can include industrial placements, so this can be either a semester-long industry project, or you can get a year-long paid industry year added to your degree course basically. And there's just a few examples here where students have done an industry placement. So it's a UK Space Agency, it's in Cambridge on a modern fuel solutions company, and places like Raymetrics UK. So the BSc year and industry students usually do their placement in the second year and then complete their final year of studies at Leicester. Whereas MPhil students may do their placement at the end of the second year or the third year. So what really we try to focus on is this element of active learning. So when we're teaching you physics, this is not just teaching you the theory and trying to get you to memorize things, but it's also teaching you how to be a physicist. And so the way we do this is we have lectures, but these lectures are followed up by workshops to help facilitate the understanding. So you do hands-on problem solving. And this is really through application of the physics that you learn to real-world problems. So we have modules like Physics Challenge that allow you to do this. In the third year projects with industry, you get to work on real-world problems, which is set by an industrial partner. And then you also, in your third or fourth year research projects, you are taught by world-leading scientists. And really, it's the cutting-edge science that they're doing at the moment. And you get a chance to really sit alongside perhaps research teams who are working on active, like international research right now, like active problems that need to be solved. So this is really, it's not just all theoretical. You really get a chance to be hands-on in terms of your problem solving and trying to practice and learning new methodologies and skills that you might need in research. And also, what I would like to stress is that we have quite a focus on how we want to support the students as well. So we do focus on building these learning communities, and we do have strong staff and student collaboration. So throughout the degree course, we have regular tutorials with a personal tutor. We have peer mentors. We're really proud about this. All staff have an open door policy. So we don't do office hours. Any student can come to any staff member at any point in the day. We have study spaces, and we have active student societies. And I think what's really important is that we want our students' well-being to be taken into account, and this is a very high priority for us. And furthermore, we do, again, talking about supporting students, we also support the diversity of our students. And so we're very proud that we are holders of a silver award from the Athena Swan Charter Award. So this is really for all protected characteristics. It's an equality charter framework and accreditation scheme. So we're really proud that just over the last year we got a silver award. And what this means is that we continually seeking to improve how we run things, how our department is, and so to make sure that all characteristics are protected and supported. So just moving on to what we teach. So all of our degrees, all of our physics degrees are Institute of Physics accredited. This means that they cover all of the core physics that the Institute of Physics approve. And these are lots of different topics such as classical mechanics, nuclear and particle physics, optics and thermodynamics in the core modules. But then we also have these optional modules, and these cover things like data science, climate physics, planetary exploration, astrophysics, and many more. So in the first and second year, typically what you'll find is that you will go to lectures where you study core physics. You'll have workshops where you do problem solving in small groups. You will have laboratory work. These are prayers and group experiments. You'll have tutorials. So these are small group teaching with your small sort of teaching groups where you sit with your personal and academic tutor, and then you do these electives, which are your choices. So these are part of the optional modules that you can choose alongside the core modules. Just to show you, just give you an idea what typical first year week could look like. So you'd have lectures throughout the week, which are roughly 5 hours, also 5 or 6 hours. You get feedback lectures, which are roughly 2 hours. You might do workshops, so this is roughly about 4 hours of your time, and then you'll do labs and group projects, so these run over 6 hours. So your contact time that you get with members of staff and other people is about 18 hours, and then there's an expectation that you do private study time on top of that, which is about 15 to 20 hours. So your total week should be roughly about 35 to 40 hours. And in the first year, the core course assessment is made up of 30% coursework and 70% exam. So all of the core modules you do coursework throughout the from the module, so that's 30%, and 70% approximately comes from the exam. And lots of this work actually includes your homework, report writing, workshop engagement, and things like that. All of the laboratory modules and the elective optional courses are 100% coursework. So the only exams you do are related to the core physics modules that you would do. As you move to the 3rd and 4th year, this is where you start to get specialised in certain things. So some of the modules that you would do is physics challenge. So this is where we're talking about much more general application of physics. You do advanced electives. So this is where you can really start to specialise in terms of the topics that you're interested. There's physics and education, where you can work with local schools and businesses. And of course, one thing that is really important, and which I think is one of the most important transferable skills, is learning how to program. So we do have courses on Python, numerical methods in C++, for instance. So this is where you can start to learn how to bring the coding element into your physics work as well. And then again, when I'm talking about the advanced electives, there's lots of specific specialist courses such as computational astrodynamics, supermassive black holes, and then lots of projects on scientific data analysis, for instance. And again, in the 3rd and 4th year project, just to give you a flavour of some of the things you can do, there are industrial research projects. So here's just a list of some of the companies that some of our physics students have done industrial research projects with. And then also there's academic research projects. So this is where you work on a pair or individual project. And this, I think, is really, really nice because lots of students really enjoy this. You get a chance to work on active and real research. And this is your chance to work as part of a research team guided by an academic mentor. And alongside this, we also have these specialisms in physics special topics. So this is where we have like a student research journal, and students get a chance to write sort of like a research project, a research paper on a piece of work that they've done as well. So just to let you know also that we recently moved buildings, so we still give the award-winning teaching provision. It remains the same. We've simply relocated to some modern premises at the moment. We have some new undergraduate labs, and these are really exciting, and I'll show you some photos on this. And this is basically where real space hardware labs, they were real space hardware labs, but they've been repurposed so that you can do your experimental labs in those. We still have the open door policy, and we have access to staff. And so at the moment, physics is sort of split between 3 buildings. We have Michelity Annex, which are shown here, and then Space Park Leicester. And just to show you some of our experimental laboratories, so this is a sort of setting where you would sit and do your lab experiments. So this is really nice, actually, because actually the lab that we're set up in now, this is where some of the detectors and some of the material, some of the instrumentation that is on the current space mission called Bepi-Colombo, which is just about to enter orbit around Mercury. Those things were constructed in these labs, so they've been repurposed, but it's quite exciting to be able to sit in a lab like this and do your experimental learning. Okay. So just to tell you briefly about our other site, which is Space Park Leicester, and actually this is where I'm based. So Space Park Leicester is like an initiative that was developed by the university, and it was made in collaboration with local, national and international partners. So it's really a world-leading cluster for innovation, research, enterprise and education in space. So in terms of education space, right now this week we've had a continuous professional development course running, which is on the fundamentals of space. In terms of space for research, lots of my colleagues and me were involved in many international planetary and Earth observation missions. So these are some of the active research we do here now. And there's also this element of space for business. So we have lots of companies that actually sit here alongside the academics. And this is quite nice, actually, because some of the undergraduates from the physics course have been able to get internships and even jobs with some of the companies that are based out here at Space Park with us. So this is really quite nice. It's a very nice resource we have where industry and academia sit together. And actually what's nice is that depending on what sort of path you choose in your degree, you as an undergraduate may get an opportunity to try to interact with some of these industrial partners. Here's just an example of some of the way that the undergraduates have come and interacted with Space Park. So in the 4th year, all of our projects gave a nice poster presentation, and we had this lovely celebration in March just earlier this year. So these are our These are our now graduated fourth year projects, but here they did a proper scientific presentation of their work, their posters, after doing a research project, and we had a lovely. We treated it just like we would a real conference, basically. So they had wine and nibbles, and they got a chance to talk to industry partners and academics and their colleagues about the research that they've conducted and their results and what they found. So this is a really nice way for undergraduates to sort of come to Space Park and sit and be amongst this very sort of professional scientific working environment. And I think that's really important because it sort of is a nice way to prepare them for when they go on to get jobs and their future employability. So just talking about employability, I think what's really important is to say that physics degrees, basically you get many transferable skills from this. And here's just a list of some of the different places where our graduates might go into afterwards. So of course some of them decide to stay on to do a PhD or stay in academia, but you know, we have people in computer programming, finance, journalism, meteorology, many different businesses. So it's really showing you that actually, you know, all of these skills like problem solving, scientific process, scientific writing, numeracy and mathematics really do support you and set you up to have a very diverse range of jobs. And I've just got a little slide here showing you what some of our graduates have gone on to do. So this is just an example showing that some of our undergraduates and actually some of our postgraduates have gone into a very diverse range of jobs. So this is anywhere from data science in CGI. We have people who are currently working at NASA, working in climate, working in carbon finance, and working in space agencies. And what we're really proud of is that they've taken their physics degree that they've done with us, and they're all contributing to and being part of the international workforce, all based on their physics and some of the transferable skills that they've learned with us. And again, just talking about recognition and international leadership. So this slide is really just to show some of the members of staff that we have in the department and what they're doing. And I think what I really like is that alongside the teaching and the research, they are continuously making an impact and having wide-reaching impact. So we have Professor Lee Fletcher, for instance, and many other staff and students who've been contributing to some of the BBC programmes that have been on at the moment, Solar System and the Sky at Night. We have Professor Emma Bunce, who just received a New Year's Honours last start of this year for her work in astronomy. And we have 3 lecturers here at the bottom, Dr. Adam Povey, Dr. Jenny Carter, and Dr. Beatrice Sanchez-Cano, who are involved in cutting-edge, international, massive space mission programs. And this is really important because these are the lecturers who would be teaching you throughout your degree, and you would also potentially get an opportunity to do a 3rd or 4th year research project with them on real and active research. And I think that's really exciting. So I'm just going to move on to the application process. So you're all aware that you can apply through UCAS, and all of the UCAS codes are available, and also the 2 new courses that I mentioned, Physics with Climate Science and Physics with Data Science are also available now. Just to let you know that the standard entry requirement for all the courses, so we have AAB for our MPhys courses and ABB for our BSc courses, and we would like the A-levels to include physics and maths. You will have an opportunity to come to one of our offer holder days, which will occur between February and April. So should you choose to come here and apply, you will be invited to an offer holder day. And once your place is confirmed, we will send you all the preparation material and all the things that you would need as we approach September. So I've just tried to preempt some of the questions that you might have. So would you need to buy lots of textbooks? So we provide all of the core text in year 1. And then we give online access thereafter. In terms of the number of staff we have roughly 40 teaching and research staff. How do the marks from each year make up the final degree? So in the first year, your final end of year 1 mark does not count towards your final degree mark, but in your year 2 and year 3 they do. So it's 33% in year 2 and 67% in year 3 for your BSc. In the MPhys, it's made up a little bit differently. So year 1 does not count to your final degree mark, but then after that it's 20%, 30% and 50% contribution from each year into your final degree mark. And you may be interested to know that we have lots of clubs and societies that you can join. So there's things like Physics Society, Astronomy Society, and then there's many, many more that you can choose from. And then roughly how many students do we have per year? So in the first year, we would typically have somewhere between 110 and 120 students. So if you apply and when you start, you'll be with about 100 or so other students. How many hours do we expect you to work? So roughly 40 hours per week. And how is your work assessed? So over the entire degree program, it's roughly about 50% exam and then roughly about 50% coursework, but this is over the entire degree program. So what I would say is if you have any questions, you can contact us on physicsug@le.sc.uk. And I've also given the email address of our physics admissions director, which is Darren Wright at le.ac.uk. There's also a phone number there. And what I'd just like to say is that, thank you for watching the talk and please do come and join us. And we're happy to answer any questions that you might have. So again, I'll just remind you of the email address. That's physicsug, so physug@le.ac.uk. And I'll just leave you with that. Thank you.
Brilliant. Thank you very much. I think maybe now would be a good time to introduce some of the other people we've had on the call. So if you'd like to introduce two of our students.
So we have some fantastic student ambassadors here. We have Avi, who you can wave, perhaps if you haven't seen. We have Elenka, and these are both third-year students who are currently, well, you'll be coming up to Christmas break, but they're available here to help answer some questions if you have any.
So we've got one question coming in just asking about the difference in workload between sort of first year, second year and third year. I don't know who wants to come in on that.
Well, seeing as we have two third year students, I don't mind if one of you want to give your interpretation of the workload.
Yeah, I'm just second for that. From where last year was quite hard to make, but from what I remember, it was a lot more personal. You know, after you go back, you study, you prepare your coursework, and then in May, in April or May, you pass your exams. Second year was similar, was a bit more coursework based, more labs. I'm now in my third year. It's very heavily, I do a lot of projects now. So for example, I'm working on my industry project that's taking up, a lot of my time. Lots less in-person lectures and more you working on your, doing individual work, being more independent, and you're working on more project modules now.
Yeah, so it's a little bit of a mixture. First and second year, you have lots of your core projects. And I think what you find is, so you have the allotted hours for lectures, workshops and labs. There's an expectation that you will do your own private study time around each of the modules that you're learning. And then you'll find that week by week, it can be a little bit different. So, for instance, our labs, they alternate over the week. So one week you might not have labs, but then the next week you do. So they alternate throughout the year. And then also you might find that you have 1 week where you have a few more deadlines, and then some weeks where you have fewer deadlines. So it sort of roughly balances out. But yeah, it works out to roughly about 40 hours per hour. 40 hours, 35 to 40 hours per week. And in the third year, as Elenka just said, your time is split over your research project, and then in the fourth year it's the same. So you have you have some of your modules, you have sort of fewer modules to do, but you have your research project alongside.
Fantastic. Got another question, which again I think probably best answered by the student ambassadors, but sort of asking what is the sort of biggest difference between A-level physics and university physics? But I also sort of want to maybe add my own little part to that question of please answer that, but also maybe give a bit of an insight of what the difference is between just, post-16 school and university. So yeah, what are the few differences there?
Yeah, I'll take that question then. So to answer that, I'd say, in general, obviously at school you do study quite a few different subjects at the same time, and you're trying to learn all of the different basics and exploring what kind of area you're really interested in. Whereas at university, you have now kind of decided what is the particular area of interest that you have. For example, for us, hopefully it's physics, and you then get to dive a lot more into this the specific areas within the subject, for example, quantum mechanics or astrophysics, like that. And the other difference I would say is you are also surrounded with 100 other students who are equally interested in the subject, and you get to make lots of different friends. You will see a lot of people who are joining you from different countries, so there's a lot of diversity, and you get to exchange ideas and work together alongside professors. So I would say that is kind of the fundamental difference between school and university life. But now, kind of going to the specific of the question, how university physics is different from A-level physics. A-level physics is going to teach you the building blocks of what fundamental physics builds on. So you will learn mechanics, you will learn some heat and thermodynamics, you will learn a bit of optics during your A level, but then when you go to university, you are going to then start building but a bit more detail onto all of these topics. So during your first year, you will kind of traverse through the basics and then start moving on to specialist electives as you move through the years, for example, quantum mechanics or condensed matter physics or nuclear physics or even particle physics and things like that. Yeah.
Brilliant, thank you. Just another question about, I think this one's specifically about the year in industry, and just asking sort of a bit more in detail how that all works and what sort of partners or I guess companies that the university is linked with.
Yeah, okay. So the year in industry, so basically you do have to have achieved a minimum percentage for your end of first year, maybe end of second year. So I think you have to have had an end of year mark of about 60%, I think, if it's correct. And basically how it works is that there's a process within the department, and you get informed about when the process is open, and then you get to apply to have a year in industry. And some of the most recent examples that we have so there was someone who was working on an atmospheric aerosol LiDAR system for high altitude pseudo satellites. So that was a company called Raymetrics UK. We've had someone who was looking at radiation environments with the European Space Agency and a company called Teledyne. And then we've had another person who was working on model fuel solutions for a company called Artec Vida in Cambridge. So they're quite wide-ranging. They're quite wide-ranging areas that you can go in. So I think we have some partnerships already with certain industries, but I think I remember some students were trying to find some industry partnerships themselves as well. So I think that's also possible. So basically, there's a process that you go through. You have to have achieved a minimum mark. I think it's 60% in your second year. So if you're on the BSc course, you would sorry, let me get that right. So so in the BSc course, you would do the placement at the end of the second year, and then you come back to do your third year. And then the MPhys, you can do it in your second year or your third year. Yeah, so it's once you get once you know what your end of year mark is, basically what it's predicted to be, you would apply through. We have a member of staff who looks after all the industry partnerships, and you would basically have a process that you have to follow, and you apply through it, and then you get selected. And I think we do have partnerships already with companies, but should there be any other additional, and I think we're probably adding to this all the time as well, but you could also potentially find your own industry partner as well. But we can give you more details about that if you want to know more specific things.
Brilliant, thank you so much. Got another question going. What's the difference between physics with astrophysics and physics with space science?
Okay, so physics with astrophysics. So here, so this is really about, you learn about galaxies, star systems, you're learning more about some of the sort of physical properties of some of the things in the universe. In space science, it has a slightly more focus on how you get into space. So some of the payloads that you have, it has perhaps a slight engineering focus as well. So it's about the types of orbits, types of missions, types of instrumentation, types of satellites, about how you actually get into space, what the space environment is like, what some of the missions are that you might build. So it's a little bit more on the project, so the space instrumentation side, and understanding, you know, the act of actually getting into space and different types of orbits, you know, and different types of payloads, rockets and things. So there's a slight difference. But what you'll find is that there's a focus in terms of planetary science, which sort of overlaps a little bit between the two. So they're quite complementary in that sense. But astrophysics is really about learning the theoretical side and the physics side of the galaxy and the environment. Sorry, galaxy, the universe, lots of things on. I'm just trying to think. I can just try to remember what some of the things that we do is like. We talk about black holes. There's star systems, how brown dwarfs are formulated, and I don't know which one of you actually have done any of the astrophysics modules, but yeah, so one is more about the theoretical understanding of the universe and the systems, and then space science is more about some of the instrumentation side and how you actually get onto it. And one of you doing astrophysics? Can you? No, you're not. Okay. Oh, Abby is.
Yeah, so I have done quite a few astrophysics modules during my time. That different kind of areas. I think you've mentioned quite a few of them. We do galactic physics. So, for example, we look at black holes and stuff. We look at quasars. We study the universe as a whole, so cosmology in general. We do some stellar astrophysics, so that's essentially study of star systems. And yeah, quite a few different exciting things, honestly, going on around the department. Exoplanetary systems as well is one of the important ones that we do. So yeah, that's all for me.
I actually, sorry.
Oh no,
I
go for
do
it.
space science, so I can give a little input on that. Right now I'm doing my module on the space environment, so we look at the magnetospheres, the planets in our solar system. We look at different asteroid family types and meteorites. I also did a really great module on astrodynamics where we use a software that NASA used called GMAP to simulate orbits and missions from, like, for example, Earth to Mars. So yeah, that's sort of what we look at in space science.
Wonderful. And I think that is the final question. So I will hand it back over to yourself to wrap up if you like.
Okay, so I hope that's given you a flavour of what we do. We're very excited that we have 2 new courses, so physics with climate science and physics with data science. And really we're responding to what lots of the companies, the industries and lots of the workforce in the UK and internationally are sort of going towards with their physics background as well. So hopefully I've given you a little bit of flavour, and I just want to remind you, if you have any questions, so there's me, there's Dan Wright and there's Phil Evans. We are all part of the admissions team, and the email address is PHYSUG, so that's phys_undergraduate@le.ac.uk. So if there are any questions, we are very happy to answer any questions. So please do contact us, and thank you very much for attending.